Now, it is now time for questions and answers, questions for the panel here. So in the room or from the web, please, don't be backward in coming forward and ask anything you like of G or of Claude or of Rod or indeed of the large-scale antenna array system team here. There's a microphone circulating, whether it's technical questions about whether this is going to come online, about the organization, about membership. Please do get some questions out there. I know there'll be some coming from the web. Who'd like to, any questions? Which one's the lighted? I can't really see. Has anyone got any questions? From the web, perhaps. Do we have anything from the web? Okay, Caroline from the, yeah. We need a microphone, yes.
Hi, am I on? Yeah. How long will it be before the technology demonstrated today will be seen in commercial networks?
Okay, well, maybe I'll feed.
So recognize that GreenTouch is fundamentally a research consortium. All of these technologies building upon one another to eventually, after 5 years, achieve this factor of 1,000. But there are intermediate points, not only just from the consortium, as you saw today, this factor of 16 antenna system that could go up to 30 or more, but as these ideas, sleep modes, and new devices and components and architectures can actually come into the marketplace much, much faster. So as they mature, they are all contributing to GreenTouch and contributing to this factor of 1,000, but can actually hit the market much more rapidly than 5 years out and then standardization and whatnot. So some of these that require a radical transformation will, of course, take longer, but others, some of the technologies that we've described today, can actually come to the market very, very quickly. Thanks, you.
Okay. Any other questions, please? Gentleman here. Yeah. Why don't you take the microphone?
Hello, yes, Peter Judge from eWeek. Peter Judge. The demonstration. I want to see it again, and I want to see you actually move the phone around to see if the beam really does follow it.
Greg?
Come up and see it afterwards. We'll do it.
Okay. Bad luck to those on the web.
I mean, we can do it now. I mean, yeah, we'll do it now. We'll do it now. Greg, if you're happy to do it now, I'm not the science man. You are. So if we could all be.
Okay. There may be other more interesting things to say, but I want to see that at some point.
They don't believe us. Okay.
I knew you really wanted to get those screens back out again, didn't you?
Yeah.
We'll have to undo it, Greg.
Are you mic'd up? No.
Yeah. Oh no. Well, we'll move the whole thing around. Yeah. There we go. There we go. The screen's on. Okay. What we're doing again is we're going to do the whole demo again, but we're going to show that it's really working. Okay. It's fair. Now, okay. So here's the big meter. This is energy. This is what you want to look at. This is the data rate, and that's just to show we're not cheating. Okay? We're not cheating. We're showing the same data rate. All right. So here we have one antenna on, and it's what we may do instead of. Well, you can see the rate will change. It adjusts the power to keep the rate constant. Okay, with just one antenna, that's all we can do. So you cover it up with your hand, cover it. It goes up and down, but it adjusts the rate, so it's back in the middle again. And when you step away, it goes back. Now, right now, we only have one antenna on, but we move it around and we see the rate stays the same. Now, the fancy stuff is I turn them all on and do the same trick, right? This is kind of turning into like a junior high magic show. It's okay. We turn a bunch of them on, we get less power. And it ought to wiggle around a bit. In fact, though, as we turn on multiple antennas, we do get certain other advantages of averaging, so it becomes much more stable. So we move it around, and it's still low. You see, the rate doesn't change very much. Yeah. It's real low when you get sort of right in the middle, but on average we save 1/16 with this technology, and it works. You kind of put your hand over it, it figures out. Well, it's going to. Oh, I killed it there, didn't I?
So it, in terms of when you block it, it's actually better than the. It's less energy and better.
Yeah, less energy and better when you block it. Yeah, there are other advantages, but we're mostly focused on the energy reduction part of it. But we're not ignoring the fact that there are other improvements we can get by using very many antennas.
Thank you. That was marvelous.
You're welcome.
Bell Lab's own Peter Snow, for those who... any other questions then, please? Here's one.
Luke Collins from Engineering and Technology. You said at the launch that this would be, or maybe it was Ben, this would be hundreds of people and tens of millions of dollars. What's your sense now that you've got 36 companies directly involved and IP structures which will allow further collaborations in terms of people and money?
Well, so there's essentially two elements for GreenTouch. There are the members, and from those members, the people who contribute directly to GreenTouch. And so as I said earlier, in the November meeting, we had over 130 people, the scientists that participate directly into GreenTouch, show up and come together for our face-to-face and discuss these issues. But of course, behind each organization, there are research teams and whatnot that feed into this pool. So, GreenTouch doesn't track the number of users or that in a budgetary sense, but it's at least as much as the things that you see today. So we just track the members and the members' contribution, not what actually goes on in addition behind the scenes that feeds into that pool. But it's, from my perspective, I could say it's, in the hundreds. Mm-hmm. Mm-hmm. That really depends on where the research is being done and those kind of organizations. We don't have any insight into that beyond the operational part of GreenTouch, which is minimum because we want GreenTouch to be focused on the research contributions, not as an overhead body bringing in expenses.
Thank you, G.
Thank you.
Do we have some more questions then, please? Anything more from the web? Anything else? Any more questions? No? We have one more here. Yes, please. Yeah.
Hi, Julian Bright from Informer. Just interested to know the sort of the profile, the membership profile that you're developing. As far as operators go, I saw Orange. I'm not sure if there were any others. Are you looking to involve more operators since they will be the main beneficiaries of this kind of technology? And also from the vendor side, what about some of the other major vendors coming into GreenTouch? I don't see a large number of vendors there at the moment.
Yeah, that's fine. And in fact, if we could just put up the membership slide, that might be also helpful as we go through this. So the membership of GreenTouch essentially has 4 elements to it. You pointed out the operators. The operators are not only the end customer to all of this technology, But the operators have a very critical role to play in GreenTouch. Not only do a lot of them actually contribute to the research directly, but remember, when GreenTouch tries to achieve this factor of 1,000, it's relative to today's network. That means that it's very, very dependent on the traffic patterns. Is traffic going to migrate from wireless to wireline to wireless? What is the access technology? What is the architecture, et cetera, et cetera? So as we optimize the energy to this projected traffic pattern, where does that traffic pattern come from? It comes from the operators, their insight, their own measurements of their system, their own key research and development into what are the future applications and whatnot. So as you could see, not only do we have large operators, but these operators come from all over the globe. So we're not just sampling a particular marketplace, European, Asia, North America. We're looking at all of them into the traffic pattern. So that's a very key piece. Of course, there are vendors. And the vendors continue to grow. There are others in the pipeline. And, you know, again, everyone has to decide for themselves the benefits of joining GreenTouch. We welcome everybody and encourage everyone to join. Universities play an extremely large role in GreenTouch because a lot of the fundamental insight, a lot of the fundamental research is coming out of the universities. And of course, we also have some of the most prominent research universities on the planet, again, from around the globe, giving it that global perspective, which is very, very important for us. And then lastly, the kind of government or research centers that are independent from vendors and other communities. And not only do you see them on the list, but you also see them in key leadership positions in GreenTouch, because they also provide this kind of glue in the ICT community in bringing together large and more diverse collaborations. So I think with all four of these constituencies, and they're all growing over the last year from around the world, you could start to get a sense of the momentum and the growth. Thanks.
Okay, we have another question.
You're very much focused on the network itself, which seems a good thing. Does there come a point when you need to look sort of outside that at where the energy comes to get onto the net, where the energy comes that is supplied to the network, sort of ways in which you might adjust base stations to use more renewable energy, and also looking outside the energy on the other side at the energy consumption by handsets, or is that too small to worry about?
I'm going to take part of that question, and I'm going to give the other part to either Rod or Dan Kilpers in the back as well. So as Claude pointed out, a lot of the initial thinking about GreenTouch was what are the topics inside of GreenTouch and what are the topics outside of GreenTouch. And when we take a look at some of the topics like screens or computers or data centers or whatnot, we look around the industry and we see very strong research collaboration and consortiums in those areas already doing that. So we don't want to duplicate efforts. We want to instead just extend out, collaborate them, link up with these other groups, and share results at a higher level. What we saw in the entire industry was a gap, a hole, in the area specifically of networks. So let me define what I mean by network. Not only is it the connectivity, as you saw, with the optics and the routers and the access and whatnot, but that network extends all the way up to the router, to the modem on one side. That little chip that kind of terminates the signal. That could be in your handset, could be in the premises equipment, but that's where we define the boundary. because others extend it beyond that. Now, having said that, though, we also recognize that the way data gets from one place to another is extremely important. That we normally think about in terms of data centers, and of course there's great consortiums in that, the Green Grid, etc. So instead, we like to think about it as content distribution. So context-centric networking, CCNs, CDNs, etc., where the network caches information in strategic locations that minimize energy. Because today, content is cached for other reasons: performance, latency, number of access hits, etc. So GreenTouch really focuses on the network, terminating with the modem chip, because that's where we saw the gap in the industry. And then inside of that, up through the layers to include content and whatnot. And you started to see that with some of the virtualization. That virtualization really is a computer. It's sitting inside the network and could be in a data center, but doesn't have to be. So the network now will do that. Now, in terms of alternative energies, of course, everything that we do benefits from offloading the energy requirements from brown energy sources to green energy sources. And we've already seen in the marketplace today remote access equipment, whether it's base stations or fixed or whatnot, powered by solar cells and wind turbines and things like that. And all of those are very, very positive and have a great impact on the society and sustainability. But we know that that has a limited amount of impact if we can't reduce the energy requirements of the network. So the goal of GreenTouch, focusing on the consumption, focusing on the efficiency of the network, is where we see the big gains, because then subsequent to that, everything builds on that. You can now start to think about large-scale solar or wind kind of augmentation. You can also start to reduce the cooling requirements, the air conditioning requirements, et cetera, that also follows with this type of equipment. So by focusing on the generation of heat, where the power is going, all of these things build upon that. And so that's really why and where GreenTouch is focused.
Were you going to hand over to Dan or to...
Yeah, is there anyone, just a sec, Luke, do you want to talk about the other links, or we covered it? Okay. Okay, great. Go ahead, Luke.
I was just wondering whether you might face some gotchas here in terms of total embodied energy, whether the sophistication and complexity needed to do some of these things might mean that you're building more kit at a higher energy cost.
So that's a fantastic question, and I'm glad that you asked it, because there are so many research groups out there and so many research projects that focus on one thing. One thing. Let's take, for example, the air interface. So we can improve substantially the air interface by focusing beams or doing whatever, but at the expense of additional computation requirements. And so everyone focuses on the link or the transport or whatnot and forgets these other pieces because their slice of the network is minimized. The beauty of GreenTouch is the fact that it looks at the entire system. So we can't cheat in that way. We can't say, okay, we've gotten the fiber optics to be really strong, or the wireless link to be very low power, because we're also including all the other parts of it. So by looking at the network holistically in that sense and doing the optimization at the high level, there will be some parts of the network, perhaps, that will actually have or require more power than is required today, because they are doing more things. There's more demand on them given this kind of architecture. But overall, there's a substantial reduction. So you will see this kind of migration from a philosophical point of view of technologies today that require a tremendous amount of energy over to those technologies that are already very efficient. So going into optics as fast as you can, because optics really does constrain the power down a fiber really well in a lossless way. So these kind of general trends, moving from the access where the energy is dissipated a lot today, making that access have a higher utilization. You saw the work from Huawei on being able to do sleep modes or something, or just take the whole thing and move it into the cloud. This kind of building or increasing the utilization of the edge is a key result. So by looking at this system holistically, there may at the end be something that we haven't considered, but given the quality of the team and the breadth of the intellect on this, I think we're in pretty good hands.
Dan, you want a word?
Let me just add. So I think G covered the topic well. But regarding embodied energy and a life cycle analysis, this is a very important issue, and we have this aggressive factor of 1,000 efficiency goal, but we fully recognize that we need to include that full life cycle picture. And so our Services, Applications, and Trends Committee has the task of looking at not only energy efficiency, but other metrics that we need to consider in our overall analysis. And so, although we're not going to improve the overall carbon footprint from that full life cycle picture by a factor of 1,000, we want to understand what are the implications of if we have this more efficient technology in the network, what does that do in terms of the embodied energy? And we're actually, Andy Stevens from the Carbon Trust was at our meeting in Amsterdam. We've been talking with folks at the Carbon Trust, Jesse and others who have been working very hard to understand not just the use phase, but the other phases of energy. And we want to incorporate some of that into our overall analysis through this SAT committee.
Great, thanks, Dan.
Can I just add something as well? It's interesting, while we have not yet done detailed embodied energy analyses of the technologies, because the things that are very early stages, it is interesting to note that quite a few of our solutions do end up appearing to be very positive from the point of view of embodied energy. For example, the line card on a chip project, which is going to greatly reduce the size and amount of fabrication involved in making that line card. And in fact, even, dare I say it, maybe I'll be contradicted by my colleagues from the wireless group, but I suspect that this device, even though it might be a little larger, is probably going to have less embodied energy because there's far less electronics in there and an equipment that drives the whole thing. So I suspect that we're going to find that many of our technologies actually do use less embodied energy than the current technologies.
Thank you, Rod. There's one from the web there.
For the universities to be part of GreenTouch, so maybe Rod can answer that. You know, what do the universities get out of it?
Yes. We and the University of Melbourne joined GreenTouch because we thought it was an incredibly exciting research area, and we have been working on it for some years, but without much interaction with other people. And we found as a university working with these great companies, we have far more motivation and more data and more stimulation, more activities, more collaborations, and it's just been, for us, a tremendous opportunity to greatly expand our research activities and to get our research team much more excited. And I think we've been much more productive working in collaboration with these other groups.
Any other questions, either from the web or from the gallery, as it were? shall we? Okay, I think we'll call it a day. Thank you very much indeed for coming here. One last word. It was interesting to hear G. Rittenhouse talk about optics a minute ago, because not many people realize that his great-great-great-grandfather was a very famous scientist called David Rittenhouse, who made George Washington's first pair of spectacles. So that is all we can offer you. But I hope that you've picked up what we were desperately keen to communicate, and I think we've done a good job of it, which is that GreenTouch is very much there, very much alive, and very much on track to fulfill these goals which it so ambitiously set itself last year and which are looming. Thank you very much indeed.